In the last video, we have seen that force exerted on a moving charge by magnetic field. So this was the scenario where in that case, the charged particle was moving in a direction which was perpendicular to magnetic field. So that is only one case, right? So we have magnetic field into the plane and charged particle was moving in this direction. So it was able to have a continuous circular path. And we have got the value of R as, so I will derive the equation once again. So in this case, mv square by R should be the centripetal force. Okay, that required for a circular path. Who will provide it? The magnetic force will provide it. What is magnetic field force? That is QVB sin theta. But here, see the direction in between V and B is 90. So that is sin 91. So here I have got the value. One V and other V have cancelled. R is equal to mv by QB. And we got the value of time period omega. How we will get the value of omega? We know V is equal to R omega. Omega is equal to V by R. So simply I can keep velocity here and transfer R here. I will get the value of omega. What is omega? V divided by R. That is QB by M. And how can I get the value of time period? Time period is equal to 2 pi by omega. And omega is QB by M. So 2 pi by omega QB by M. So time period is equal to 2 pi M divided by QB. Correct, right? V by R is QB by M. So QB by M, time period. This was the time period. With this time period, that will have a continuous circular motion. If at all, if the magnetic field is here. So previous case, the velocity was perpendicular, going like this. So this is into the plane. So I'm just rotating it in this direction. Okay, so magnetic field going in this way will be into the plane. Now, previously we had a magnetic field, velocity in this direction, which is perpendicular to the magnetic field. But here, velocity is in inclined direction. Now, what will happen to the movement of charged particle? So this velocity can be split into two components, V cos theta and V sin theta. I hope you know how to do the rectangular, how to get the value of rectangular component. But anyway, I'll explain it. Let's say you have a velocity in this direction. So I will formulate a triangle. So this is horizontal component, this is vertical component. Now this is horizontal, right? This is vertical, and this angle is theta. This is our velocity. Now we have to find the horizontal component. So cos theta is equal to adjacent by hypotenuse, Vs by V. Now sin theta is equal to opposite by hypotenuse, Vr by V. From here cos theta is equal to, Vh is equal to V cos theta. Here Vr is equal to, V vertical is equal to V sin theta. So that is what I have done here. V sin theta and V cos theta. V cos theta and V sin theta in this way. Horizontal and vertical. Now, see, vertical component V cos theta is parallel to magnetic field. Now, if a velocity vector is parallel to magnetic field, so V cos theta makes zero angle here. Correct? The velocity vector makes zero angle with magnetic field. Now, what will be the force? Force, you know, that is cross product. Q V cross P, right? The value is Q V B sin theta. Now here theta means in between V cos theta and, so I will mark it as alpha here. Okay. So here what is the angle between V cos theta and magnetic field? 0. So sin 0 will become 0 and force in that direction is 0, which means force 0 means acceleration 0 because F is equal to ma. So ma is equal to 0 means m cannot be 0, which means acceleration is 0. So if acceleration 0 means V cos theta will be unaffected. The value of V cos theta will not change. Now what will happen to V sin theta? So V sin theta is perpendicular to this one. So that is this case. So V sin theta will be having a circular motion. So I will prove it here. So V sin theta is perpendicular to the magnetic field. So if it is perpendicular, then sin alpha will become sin 91. So force is Q. Here V is V sin theta into B. So this is the force here. With v sin theta common, with v cos theta common, it is 0. So acceleration is 0. V modulus of v remains same. So modulus of v cos theta it is. Okay, that remains same. Now v sin theta, what will happen? So this v sin theta, with that it will have a circular loop, which means that will be used as mv square by r. M into v sin theta square by r. So anyway, what will happen? This now we will have this. Now we will have a circular motion and associated with a circular time period. How can I get the value of circular time period? Here is the value of time period, or I can get the value. Yeah, I can keep this value itself. Okay. So yeah, keep the value. Time period is equal to 2 pi m divided by qb. Now time period is independent on velocity. From this equation we have learned, and even time period is independent of radius. Do you have a radius term here? No. Do you have a velocity term here? No. Right. So we know that with this time period it will be revolving. So it is independent on v sin theta. It is independent on radius on which it is revolving. It is even independent on the velocity and radius. Yes. Okay. Only depends on mass q and v. So with this time period it has to rotate, but v cos theta horizontal velocity has to remain unchanged, which means our horizontal velocity should be there in this direction, and v sin theta should take a rotational should have a rotational motion. So how both can be achieved at the same time? That can be achieved in this way. It will go, and from other side it will come, and it will go, it will come, it will go in this direction. See, v cos theta have to be the same, right? So with v cos theta that will have a linear motion, and with v sin theta it will have circular motion. So what will be the case? So it have to go in this direction and it has to rotate. So it will rotate in this direction, spiral. It will go. Okay. What is the reason for this motion? That is v cos theta. What is the reason for circular motion? That is v sin theta. Hope this is very clear with you. Okay. Now, how to get the value of pitch here? What is pitch? That is the distance in between two nearby circles. So we know that this will happen. I mean, when the charge is here, that will come to this position after one complete circular motion, and for that this will be the time taken. See, from here that will have a rotational motion and come back to this position, the same level, after one time period. So this is the time period, and by that time we need to know what is the total distance traveled. But we know that velocity in this direction is the same, v cos theta. So velocity in the time period will be giving us the pitch. So pitch is equal to, what is the pitch? We know velocity v cos theta remain unchanged, remains the same. So v cos theta in the time period. So 2 pi m divided by qb is the time period into v cos theta. This is the pitch. Important. So all these derivations are very, very important. Make a note of it. Thank you.